Okay, hi, we have another problem here that we're going to solve for theta on the interval of 0 to 2 pi. And again, what we need to note here is that somehow, some way, we have to solve for our cosine, so we have to isolate it. But problem is that now I've got a square, and once you square something, it makes your function essentially behave like a quadratic in this sense. So just remember that your highest exponent determines the what type of function it is, and in this one we're talking about a square, so we're going to pretend that, the idea of it's like a quadratic. That's my linear term, and then this is my constant. So the goal here is, remember, got to set it equal to 0. So that's what I'm going to do. So in this case I need to subtract 1, so I'm left with 2 cosine squared x minus cosine x minus 1 is now equal to 0. Subtract 1 from both sides and I get this statement. So now what I need to do is I need to factor this into my looking at this term I can go into, and I can make it a binomial times a binomial, because here I have essentially a quadratic trinomial, because here's my one term, here's another term, there's 3, so that makes 3 terms, so it makes it a trinomial. So I'm going to go ahead and factor this into a binomial times a binomial. I'm going to look at 2 and negative 1, so at this point here I'm going to come up here and go, okay, this is 2 cosine x. That has to be one of the factors, because it's a 2, and its only other factors are 2 and 1. So then the other one has to be cosine x. And now I'm going to look, can I even do this? And if I can't, there's some other ways that I can look at it. So negative 1. So can I make negative 1 from negative 1 and 2? Well, it turns out that I can. If I make this negative 1 and I make this positive 1, I then have this then set equals to 0. So what I do from here then is it goes back to the idea of the algebra 2 concept, is that now I begin to set each factor here equivalent to 0, because if a factor times a factor that gives me 0, one of them has to be 0. It's the only way I can do it. So here we go. I now have 2 cosine x plus 1 equals 0. And I have cosine of x minus 1 equals 0. So then this is back to a linear problem. So I broke in my quadratic into linear so that I can solve for it. So I minus 1 and I divide by 2, and what you'll have here is that cosine of x equals negative 1/2. Again, subtract 1, 0 minus 1, negative 1, divide by 2, negative 1/2. So at this point, what I'm going to look for on the interval of 0 to 2 pi, where does cosine give me a negative angle? Well, cosine is negative in quadrant 2 and in quadrant 3. So what I now need to look for is, what is the reference angle? Well, cosine is 1/2 at 60 degrees. So 60 degrees on the 2 pi interval is pi over 3. So I have now that my reference angle is pi over 3, but I'm in the second quadrant. So pi over 3, it's using that reference angle here. In the second quadrant, I'm going to get that x is equivalent to, well, pi minus pi over 3 keeps you in the second quadrant. So that gives me 2 pi over 3. And if I were to add pi over 3 to that, that would put me into the third quadrant. So I have 4 pi over 3. So that's how I get those two. So then this one here, I now need to look at, so I add 1, and you're going to get cosine of x equals 1. So now I need to look at, when does cosine of x equal 1? I need to take a look at my interval, because cosine of x is 1 at 0, 2 pi, 4 pi, 6 pi, 8 pi. So problem is that my interval says that it can include 0, but it can't include 2 pi, so this answer has to be when x is 0. So then my answers here, in radians, is 2 pi over 3, 4 pi over 3, and 0. So I hope that helps.